This is the third video in our series on risk analysis in food safety of 4 videos. In part 1, we uncovered why risk analysis exists, why zero risk is a myth, and how systems like Codex and the World Trade Organization guide food safety globally. In part 2, we broke down the structured 4 steps of risk assessment, from identifying hazards to characterizing exposure and estimating risk. Today, in part 3, we go hands-on, and we'll do it in 2 episodes. In this first part, we'll walk through how to build a structured risk assessment using qualitative and semi-quantitative methods. In the second part, we'll tackle strategic tools like comparative ranking and MCDA to help you decide not just what's risky, but what should be done first. So whether you're new to risk analysis or refining an existing system, both parts of this guide will give you the full picture. Whether you're a food safety professional, an auditor, or a decision maker, this video will show you how to build a structured risk assessment, choose between qualitative, semi-quantitative, and decision-based models like multi-criteria, decision analysis, or MCDA. Prioritize what matters most. If you haven't seen the previous 2 videos yet, feel free to continue here and come back later. But together, they form the full picture. Every company wants to manage food safety risks, but not every company starts with the same tools, data, or resources. That's why a good risk assessment process is not just a compliance exercise, it's a strategic tool. Here's what a strong risk assessment allows you to do. Map out your entire landscape: ingredients, products, suppliers, and processes. Reflect on where hazards are most likely to occur. Evaluate each one, individually or in groups, based on real-world context. Identify which risks are most significant. Prioritize actions where they matter most. In food safety, resources are always limited. You can't address everything at once. So the goal is to work systematically. 1. Identify all hazards. 2. Assess likelihood and impact. 3. Rank them. 4. Act proportionally. But here's the catch. There's no one-size-fits-all method. You have to choose the tool that matches your data, your needs, and your goals. Let's walk through the main options. Now that we've set the stage for why different tools are needed, let's break down the 3 main types of risk assessment and why they aren't interchangeable. 1. Qualitative risk assessment. This is the most commonly used approach, especially in industry, and uses descriptive terms like low, medium, and high, sometimes expanded to 5 levels, to evaluate likelihood and severity. It's quick and practical, ideal when data is limited and decisions can't wait. But it can also be subjective if those categories aren't clearly defined. The good news? There are smarter ways to make it more consistent and evidence-based, which we'll explore next. It uses descriptive categories, like low, medium, or high, to evaluate 2 main dimensions. Likelihood. How probable is it that harm will occur? Severity. If it does happen, how bad will it be? It's simple, fast, and requires minimal data. But not all matrices are created equal. Some versions are vague or overly subjective. Fortunately, there are much better ways to structure them, something we'll explore in the next scene. 2. Semi-quantitative risk assessment. This method takes things a step further. Instead of just labeling risks, it assigns numbers, usually 1 to 5, to likelihood, severity, and sometimes other risk factors. You can add weights to give more importance to certain criteria and calculate a risk score. It's more detailed, less subjective, and still manageable using tools like Excel. We'll show you how this method helps prioritize risks with greater confidence. 3. Quantitative risk assessment. This is the most complex and data-intensive method. It involves statistical modeling, simulations, and probabilistic estimates, often down to decimal points and probability curves. It's typically used by government agencies and international bodies for microbiological risks or chemical exposure models, where the stakes and the uncertainties are higher. But unless you're designing national regulations or building a full exposure model, you likely don't need this level of detail. That's why today, we'll focus on the first two and introduce you to MCDA, Multi-Criteria Decision Analysis, a powerful tool for comparing complex options. Let's now take a closer look at how qualitative risk assessment really works and how to make it more useful and less subjective in real decision-making. Let's start with the method most companies rely on: qualitative risk assessment. It's the most common approach in the food industry. Fast, practical, and ideal when decisions can't wait and data are limited. This method evaluates two key dimensions: likelihood. How probable is it that the hazard will occur? Severity. If it does occur, how serious are the consequences? Traditionally, this is done using broad categories like low, medium, and high, sometimes expanded into 5 levels. But here's the problem. Those terms are highly subjective. What feels high to one assessor might be medium to another. Even within the same company, two people can interpret the same situation very differently. That's why structure matters. A good qualitative risk assessment must go beyond vague terms and use clear, concrete definitions for both likelihood and severity. Think about it this way. Instead of simply saying low, medium, or high, what if we described risk in real, concrete terms? For likelihood, we could ask, is this event practically impossible? Something that's never happened before? Or not expected to occur, but still within the realm of possibility? Could it realistically occur under certain conditions? Or is it known to occur, something we've actually seen before? And finally, is it a common occurrence that happens often in the industry? Now, combine that with severity. Not just minor or major, but what it truly means for human health. At the lowest end, maybe it causes no real harm, just a minor quality defect. A step higher, consumer discomfort, perhaps a mild stomach upset. Then, illness, something that makes people sick. Beyond that, hospitalization, a serious outcome that demands medical care. And at the top, the ultimate consequence, fatality. When you define risk in this way, it stops being abstract. It becomes personal. It becomes human. But here's something many people overlook. Most companies color code their matrices: green for low, yellow for medium, red for high, arranged symmetrically like a perfect square. It looks neat. But does it actually make sense? Imagine this. You're assessing a hazard that's very unlikely to happen. But if it does, it could kill someone. A symmetrical matrix might place that square in the orange zone, medium risk. But let's be honest. If your product could cause even a single death, can that ever be considered medium? Take a real-world example. Years ago, a brewery used diethylene glycol, a toxic industrial chemical, to cool its beer tanks. A small leak went unnoticed, and consumers drank beer contaminated with the substance. The likelihood of that leak was low. But when it happened, people died. That's not an orange box on a chart. That's bright red. The lesson? Risk matrices should reflect the true impact of severity, not just mathematical symmetry. Even rare events with catastrophic consequences demand serious attention and proactive control. That's what a mature, responsible risk culture looks like. See the difference? Instead of subjective adjectives, we use specific observable criteria. We move from abstract opinions to tangible outcomes like illness, hospitalization, or fatality that anyone in the organization can interpret the same way. The same applies to likelihood. Phrases like not expected to occur or known to occur are far less open to debate than medium or high. And while this approach is qualitative, you can easily make it more systematic by assigning simple numeric values, for example, 1 to 5, and calculating a total score using Excel. This makes comparisons and prioritization far easier. But here's the key principle. Even though qualitative assessments are widely accepted, they must still follow clear rules to ensure reliability. The level of detail should always be proportional to the level of risk and the resources available. In other words, the higher the risk, the deeper the analysis. The lower the risk, the simpler the approach can be. When applied consistently, qualitative risk assessment becomes much more than a basic checklist. It becomes a structured, transparent decision-making tool. It helps companies identify hazards across products, ingredients, and processes, then focus resources where they truly matter most. Next, we'll explore how to bring more nuance and numerical precision into the picture through semi-quantitative and ranking methods that bridge the gap between simplicity and analytical power. Now that we've seen how a well-designed qualitative matrix can sharpen our understanding of risk, the next step is asking, can we make it even more structured without making it complicated? That's where semi-quantitative risk assessment comes in. Think of it as a bridge. It sits between the simplicity of descriptive terms and the depth of full-blown quantitative analysis. It adds just enough structure to improve consistency without requiring a PhD in statistics. Here's how it works. Instead of only choosing a color or a phrase, we assign numeric values to both likelihood and severity. Let's say likelihood ranges from 1, rare, to 5, frequent. Severity ranges from 1, minor, to 5, fatal. We multiply these two to get a basic risk score. For example, a hazard that is likely, 4, and causes illness, 3. A score of 12, but it doesn't stop there. To refine things further, we can introduce weighting factors, especially if some criteria matter more than others in your company's context. For example, you might assign more weight to hazards involving allergens, or prioritize those that affect vulnerable populations, like infants or the elderly. This creates a smarter, ranked list of priorities, so you know exactly where to focus first. And yes, you can do all of this in Excel. With a few formulas, drop-down menus, and conditional formatting, you can build the matrix, assign weights, auto-calculate risk scores, visually rank your hazards from highest to lowest. Just a clear, structured tool that helps you move from intuition to insight. In fact, many countries and agencies already use this method. So yes, this isn't just theory. It's a practical, evidence-based approach that's shaping real decisions every day around the world. And here's the best part. By using this method, you're not just classifying hazards, you're justifying decisions, building internal alignment, and creating transparency across your team, your suppliers, and your regulators. Before we dive into how to compare risk priorities across multiple items, let's pause for a moment. So far, we've seen how to build a better qualitative assessment and how to sharpen that with a semi-quantitative model that brings structure without complexity. But what happens when you're dealing with a long list of decisions to make? Multiple suppliers, products, or inspection targets? That's when you need something even more strategic. In the next episode, we'll unlock that next level. We'll show you how to use comparative and decision-based tools like multi-criteria decision analysis to rank what matters most, reduce bias, and allocate resources with confidence. If you've ever asked, how do I decide who to inspect first, or which product needs the most oversight? You won't want to miss Part 4.